Good morning. Warm welcome to all for this GATE coaching class organized by Erode Sengunthar Engineering College, sponsored by AICTE Prerana. In this session, we are going to see about block diagram reduction technique and signal flow graph. Belongs to control system subject. I am Immanuvel Bright, Assistant Professor, Erode Senguthar Engineering College, Tamil Nadu. First of all, block diagram. Block diagram is the pictorial representation of the system. Block diagram reduction technique used to find the overall transfer function of the system. The following rules can be used for block diagram reduction technique. Rule number one: combining the series block. This rule combine the cascade block into single block G1 into G2. Rule number two: combining parallel block G1 and G2 into single block G1 plus G2. Rule number three: moving branch point ahead of the block. Moving branch in this rule, moving branch point after the block. This rule used to move the branch point after the block, then add the 1 by g to the branch point. Next, rule number four: moving branch point before the block. This rule used to moving branch point in before the block, add g in the branch point. Rule number five: moving summing point after the block. This rule, summing point moved into after the block, then combine the block, add g into the summing point. Rule number six: moving the summing point before the block. This rule used to moving summing point before the block. In this rule, add 1 by g into the summing point. Next, rule number seven: interchanging the summing point. This rule, interchanging different summing point. Next, rule number eight: splitting the summing point. This rule, split the one summing point split into the two summing point. Next, combining the summing point. This rule used to combining the various summing point into one single summing point. Next, rule number 10: elimination of the feedback loop. The feedback is negative, then the formula is g divided by 1 plus gh, and same time eliminating the feedback loop. The feedback loop is positive, means the formula is g divided by 1 minus gh. These are the block diagram techniques rules. The 11 rules used to the reduce the block diagram and find the overall transfer function of the system. Next, one example for the block diagram reduction technique. The problem is determine the overall transfer function C of S divided by R of S for the system shown in figure. The figure is uh, one three summing points and four blocks and two feedback loops. Step by step procedure to reduce the block diagram, and finally we get overall transfer function of the system. First, step number one: moving branch point before the block. This branch point moved into before the block. This is the first step. Next, second step: the branch point moved into before the block. Then second step: combining the blocks in cascade and rearranging the branch point. Cascade means combining the series block G4 and H1 combined into G4 into H1 and rearranging the feedback loop. This is the step number two. Next, step number three: eliminating the feedback path. Eliminating the feedback path means the feedback path G3 into H1 and G4. This path first eliminate to the feedback loop. This is the used to loop number three. Then we will get final block diagram. This block combining the blocks in cascade and eliminating the feedback path. First, combining the cascade path G2 and G3 divided by 1 plus G4 H1 and H3, combining the cascade block, and we will get single block. Then combining the, sorry, next eliminating the feedback path, and finally we get G2 divided by G3 divided by 1 plus G3 G4 H1 plus G2 G3 H2. Then next, finally combining the cascade block or series block, first G1 block and G2 G3 divided by 1 plus G3 G4 H1 plus G2 G3 H2. Finally, final step, eliminating the feedback path, this two feedback path G4, and eliminating the feedback path rule number 10. Finally we get G2 G1 G2 G3 divided by 1 plus G3 G4 H1 plus G2 G3 H2 plus G2 G1 G2 G3 G4, and another one block G4. These two blocks are series. Then used rule number 1, combining cascade block, we will get final answer C of S divided by R of S equal to G1 G2 G3 G4 divided by 1 plus G3 G4 H1 plus G2 G3 H2 plus G1 G2 G3 G4. This is the overall transfer function of the system. This is the final answer of the problem. These problems, various rules of block diagram reduction technique is used to find the overall transfer function of the system. Our aim is reduce the multiple block into the single block using block diagram reduction technique. Finally we get overall transfer function of the system. This is main find the overall transfer function of the system. And block diagram reduction technique, 11 rule is mainly used to find the overall transfer function of the system. Next, another one example of block diagram reduction technique. This using block diagram reduction technique, find closed loop transfer function of the system whose block diagram reduction is shown in figure. These problems, various blocks and summing point and branch point is there. This problem, our aim is multiple blocks reduced to single blocks using block diagram reduction technique. We are using 11 rules used to find the overall transfer function of the system. Step by step, reduced to multi blocks into the single blocks. First step number 1, moving branch point before the blocks. This branch point before the block, before the G2 blocks, and we will get the block diagram. Uh, this moving, okay, moving this branch point before the G2 blocks and add to the branch point H1. Then step number 2, combining the blocks in cascade and eliminating the parallel blocks. First combining the series block G2 and G3, then combining the parallel block G4, and another series block G2 and H1, combining the series block. And then finally we get the block diagram. Step number 3 is moving summing point before the block. This summing point move to the G1 block. Then rearrange the block diagram. Step number 4, interchanging the summing point and modifying the branch point. This step, interchanging these two summing point and some modified the branch point. Then step number 3, eliminating the feedback path and combining the blocks in cascade. First eliminating this feedback path G1 and G2 H1, and we will get single block. This block combined into the this block G2, G3 plus G4. These two blocks are series. Then use it to rule number one. Combining the series block, we will get G1, G2, G1 and 2, G2, G3 plus G4 divided by 1 plus G1, G2 and H1. This block and this block are feedback. So step number 6, eliminating the feedback path. Then last finally one feedback, eliminating the feedback path. Then finally we get G1, G2, G3 plus G1, G4 divided by 1 plus G1, G2, H1 plus G2, G3, H2 plus G4 and H2. This is the overall transfer function of the system. This sum also used various rules, and finally we get single blocks. This single block is the overall transfer function of the system. Log diagram reduction technique is very simple. So we will now 11 rules, then easily find out the overall transfer function of the system. This is the main parts of control system subject. Final step also reduced final feedback line. This feedback have no blocks, so the feedback value 1. So final answer is eliminating the feedback path G1, G2, G3 plus G1, G4 divided by 1 plus G1, G2, H1 plus G2, G3, H2 plus G4, H2 plus G1, G2, G3 plus G1, G4. This is the final answer of this above problem. This is the overall transfer function of the system or block diagram. Next, we will see about next topic, signal flow graph. Signal flow graph is the graphical representation of the system. The signal flow graph, Mason's gain formula used to find the overall transfer function of the signal flow graph. The explanation of term used in signal flow graph. This terms used for the signal flow graph. First node is the point representing variable or signal. Next branch is the directed line segment joining two nodes. And then transmittance, the gain acquired by the signal when it travels from one node to another node is called transmittance. Next, input node or source is the node that has only outgoing branch. Next, output node or sink is the node that has only incoming branch. Next, mixed nodes, it is the node that has both incoming and outgoing branches. Next, path is the transversal of connected branches in the direction of the branch arrows. Next, open path starts at the node and ends at another node. Next, closed path starts and ends at same nodes or the closed path. Next, forward path, it is the path from an input node to output node. These are the various terms used in signal flow graph. Next, forward path gain, it is the product of branch transmittance of the forward path. Next, individual loop, it is the closed path starting from a node and after passing through the certainty of the graph arrived at same nodes without crossing any nodes more than one. Next, loop gain, it is the product of branch transmittance of the loop. Last ones, non-touching loops. If the loop does not have common node, then they are said to be non-touching loops. This is a common terms used in signal flow graph. Next, mainly Mason's gain formula is used to overall transfer function of the signal flow graph. So we know that important of Mason's gain formula. This formula only find the overall transfer function of signal flow graph. The Mason's gain formula is used to determine the transfer function of system from signal flow graph. The transfer function of the system T of s equal to C of s divided by R of s. Mainly the Mason's gain formula states the overall gain of the system. The Mason's gain formula is transfer function equal to 1 by del summation of k pk and del k. This formula T or T of S means transfer function of the system. PK means forward path of kth forward path. Next, K means number of forward path in the signal flow graph. And del equal to 1 minus sum of individual loop gain plus sum of gain product of all possible combination of two non-touching loop minus sum of gain product of all possible combination of three non-touching loop plus sum of gain product of all possible combination of four non-touching loop, and continuously 4 and 5 and 6. Last, del k equal to del for the part of graph which is not touching kth forward path. This is the Mason's gain formula. This formula is mainly used for overall transfer function of the signal flow graph. Next, we will see about one example problem of signal flow graph. The problem is find the overall transfer function of the system whose signal flow graph is shown in figure. This figure is the signal flow graph. Signal flow graph means graphical representation of the system. This is the graphical representation of the system. The uh, this signal flow graph is used to overall transfer function of the system using Mason's gain formula. Step by step procedure used to find the overall transfer function of the system. First, step number 1, find forward path gain. We all know that forward path means already know that forward path means it is the path from input node to output node. This problem input node is R of S, node number 1. Next, output path is node number 8. So path travel from input node to output node. This is the forward path. This problem the problem two possible forward path is possible. The first forward path is straight forward path. This forward path travel between 1, 2, 3, 4, 5, 6, 7, 8. This is the first forward path, straight forward path. Next, another one forward path is node 1 to 2 to 5 and 5 to 6 and 6 to 7, sorry, 6 to 7 and 7 to 8. This is another forward path. So this problem possibly two forward paths. So number of forward path k equal to 2. Then draw the two forward path. Then find the forward path gain. Gain means multiply the all gain, all values, multiple by all values is the forward path gain. This first forward path multiple into all values G1, G2, G3, G4, and G5. This is the first forward path gain. P1 equal to G1, G2, G3, G4, and G5. Next, second forward path gain. This forward path gain multiple into all values G6, G4, and G5. So gain forward path P2 equal to G4, G5, G6. This is the forward path gain of above signal flow graph. Next, step number 2, individual loop gain. Individual loop means the path travels from say starting point and ending point as same nodes is the individual loop. This problem possible three individual loops are possible. First loop number 1, 3 to 4, 4 to 3. This is first to individual loop. And next, 3 to 4, 4 to 5, 5 to again 3. This is another individual loop. Next, 6 to 7, 7 to 6. So three individual loops are possible. This is loop number 1, this loop number 2, and loop number 3. Then find the loop gain of individual loop. Loop gain means multiple into by various value of the individual loop. So loop gain of individual loop 1 means the values multiplied by into first loop. So P11 equal to minus G2 into H1. Next, loop gain of individual loop 2 means multiple into values in second loop. So P21 equal to minus G2 G3 H2. Next third loop value G4 and minus H3. So loop gain of individual loop 3 equal to P31 equal to minus G5 and H3. These three values of individual loop gains. Next, step number three, gain product of two non-touching loop. Two non-touching loop means already we know non-touching loop. If the loop does not have common node, then there are said to be non-touching loop. So combine the individual loop into two loops. These loops are non-touching means they are noted into combination. This problem, two non-touching loops are possible. So first combination is G2 H1, second one G4 and H3. So combine the two individual loops. So gain product of first combination of two non-touching loop means multiple into two individual loop values P1 P31 equal to G2 G5 H1 H3. Next, gain product of second combination of two non-touching loop means combined into two individual loops second combination. So multiple into two individual loops values equal to G2 G3 G5 H2 and H3. These are the gain product of two non-touching loops values. Next, step number 4, calculation of del and del k. Del means already we know that 1 minus sum of individual loop gain plus gain product of two non-touching loop minus gain product of three non-touching loop. This problem, there is no three non-touching loop combination. So the formula is 1 minus sum of individual loop gain plus gain product of two non-touching loop. Then substitute these values. Finally, we get del value 1 plus G2 H1 plus G2 G3 H2 plus G5 H3 plus G2 G5 H1 and H3 plus G2 G3 G5 H2 and H3. This is the del value. Next, del 1 equal to 1. 1 means not there is no part of graph which is not touching with first forward path. This means first forward path, all loops are touched into first forward path. So del 1 value equal to 1. Next, del 2 equal to 1 minus of G2 H1 equal to 1 plus G2 and H2, sorry, G2 into H1. This second forward path, one individual loop is not touched. So 1 minus non-touching loop value. So the finally the del 2 value 1 minus non-touching loop values minus G2 H1. Though, so final value is 1 plus G2 and H1. Then finally find the transfer function of the system. So find the all values, substitute into Mason's gain formula. So the Mason's gain formula 1 by del summation of k and pk del k. This problem two forward paths. So k value equal to 2. So the formula is 1 by del p1 del 1 and p2 del 2. Then P1 and del 1 and del value substitute into Mason's gain formula. Finally, we get the final value is G2, G4, G5 into G1, G3 plus G6 divided by G2 plus G6 H1 divided by 1 plus G2 H1 plus G2 G3 H2 plus G5 H3 plus G2 G5 H1 H3 plus G2 G3 G5 H2 and H3. This is the final answer of signal flow graph. This is the overall transfer function of the system. Another one example is the signal flow graph for the feedback control system shown in figure. Determine the closed loop transfer function. This problem also find the closed loop transfer function. Find the closed loop transfer function is means Mason's gain formula is used to find the transfer function of the signal flow graph. This is the signal flow graph. Signal flow graph means a graphical representation of the system. Then step by step procedure to find the transfer function of the system. We all know that first forward path gain. This some two forward paths are possible. All know that forward path means the path travel from input node to output node. This problem, input node is R of S, output node is C of S. So two possible combinations. First, straight forward path, 1 to 2, 2 to 3, 3 to 4, and 4 to 5, and 4 to 6. Sorry, 5 to 6. This is the first forward path. Next, second one is uh, path travel from 1 to 2, 2 to 3, next to 3 to 5, and 5 to 6. This is the second forward path. Then find the forward path gain. Forward path gain means multiply all value of the forward path. First forward path is P1 equal to G1, G2, G3, G4, G5. Next, second forward path P2 equal to G1, G2, GH, and G5. This is the two forward path gain of a signal flow graph. Next, the individual loop gain. Individual loop gain. The path travel from starting node to same starting node is the individual loop. This problem, four individual loops are possible. First individual loop is travel from two to three, again three to two. This is the first individual loop. Next individual loop three to four, and again 4 to 3. This is the second individual loop. And uh, path travel from 4 to 5, and again 5 to 4. This is the third individual loop. And another, this problem, another individual loop is possible. This individual loop is 3 to 5, and 5 to 4, and 4 to 3. This is your individual loop, the closed path. So this problem, four individual loops are possible. Then we can get individual loop gain. Individual loop gain means multiple by the values into the loop. So P11 is the loop gain of individual loop gain. P1 equal to G2 into H1. Next, loop gain of individual loop 2, P21 equal to G3 H2. Next, third one, loop gain of individual loop P31 equal to G4 and H3. Next, loop gain of individual loop 4 P41 equal to G6 H2 and H3. This is the fourth loop, individual loop gain values G4, H3, and H2. So multiple into all values, we can get P41 equal to G6, H3, and H2. These are the loop gain of individual loop. This problem, four individual loop are possible. So we can get four individual loop gain P11, P21, P31, and P41. Next, gain product of two non-touching loop. Non-touching loop means combined to two loop of individual loop. That two loops are non-touching means two non-touching loops. This problem, four individual loops, and compare into two loops, loop number one and two. These loops are touching loops. So next, loop number 1 and 3, these loops are non-touching loops. So we can note that non-touching loop 2 to 3, and 3 to 2 on loop, and 4 to 5, 5 to 4. These two loops are non-touching loops. So first, this is the first combination of two non-touching loop. Next, another all combinations, all loops are touched. So that this problem, only one combination of two non-touching loops. So two non-touching, gain product of two non-touching loop means combined with two non-touching loops, sorry, combined with non individual loop values. So this value is gain product of first combination of two non-touching loop P12 equal to G2, G4, and H1 and H3. In this problem, only one two non-touching loop is possible. There is no three non-touching loops. So next moved into calculation of del and del k. First, we all know that the del formula 1 minus sum of individual loop gain plus gain product, all possible combination of gain product of two non-touching loop minus all possible combination of gain product of three non-touching loop. This problem, there is no three non-touching loop. So formula, the del formula is 1 minus sum of individual loop gain plus all possible combination of gain product of two non-touching loop. So substitute into P1 minus P11 plus P21 plus P31 plus P41. These values are individual loop gain. Next, plus P12. P12 means gain product of first combination of two non-touching loop. All values substitute into the above step. Then final answer is 1 minus G2 H1 and G3 H2 minus G4 H3 minus G6 H2 H3 plus G2 G4 H1 H3. In this problem, there is no part of graph which is non touching with forward path 1 and 2. So del 1 and del 2 value is 1. Then last step, find the overall transfer function of the system. This step, Mason's gain formula is used to the transfer function of the system. So the Mason's gain formula is T equal to 1 by del summation of k pk del k. This problem two forward paths. So k value equal to 2. So formula is 1 by del into P1 del 1 plus P2 del 2. Then substitute the P1 del 1, P2 del 2 and del values into the Mason's gain formula. Then final answer of the problem is equal to G1, G2, G3, G4, G5 plus G1, G2, G5, G6 divided by 1 minus G2 H1 minus G3 H2 minus G4 H3 minus G6 H2 H3 plus G2 G4 H1 H3. This is the final answer of the above problem. This final answer is the overall transfer function of the signal flow graph. In this method also Mason's gain formula is mainly used for the overall transfer function of the signal flow graph. So signal flow graph method, we all know that very important of Mason's gain formula. This formula is designed this formula is mainly for signal flow graph method. So we all know that this formula is very important of signal flow graph. Next, another one problem. This problem somewhat different to the above last problems. This problem is draw a signal flow graph and evaluate the closed loop transfer function of system whose block diagram is shown in figure. This last two problems, the signal flow graph is there, but this problem only block diagram is given. So first converted block diagram into signal flow graph. So last two problems, there is no conversion between block diagram and signal flow graph. In this problem, first step converted into block diagram into signal flow graph. First noted nodes, a summing point and branch points are node. In this problem, R of S is the input node and C of S is the output node. So R of S node selected node number 1 and this branch point is the node number 2. So branch point and summing points are selected into nodes. So first input node R of S. Next this branch point is node number 2 and the summing point is node number 3 and this summing point is node number 4. Sorry, this branch point is node number 4. Next this summing point is node number 5. This branch point is node number 6. Next this output node is 7 Next, this summing point is node number 8. These are the different nodes of above block diagram. Next, these nodes connected into path and arrow mark. So finally we get the block diagram into signal flow graph. First, node number 1 to 2, node number 1 to 2, this value is no value, so the value is 1. Next, node number 2 to 3, there is no value, so the value is 1. Next, node number 3 to 4, the value is g1, g1 noted to the block diagram, sorry, signal flow graph. And node number 4 to 5, the values g3 and the loop g2. And node number 5 to 6, there is no values there, so the value is 1. Next, there is 6 to 7, there is no value, so the value is 1. Next, path from 6 to 8 and 8 to 3. 6 to 8, the values h1. 6 to 8, the values h1. Next, 8 to 3, the value is h2. 8 to 3, the values is h2. The value, the summing point sign is negative, so the value is minus h2. Next, the summing point, sorry, the node 2 to 8, the value is g4, the summing point sign is minus, so the values minus g4. This is the conversion of block diagram into signal flow graph. Then already know that same procedure to find the overall transfer function of the system. First, only additional step to find the block diagram into signal flow graph. And another steps are same to the above two problems. Next, easy to convert signal flow graph, and we are find the overall transfer function of the system. First step, find the forward path gain. This forward path means the path travels from input node to output node. These problems, four forward paths are possible, so the number of forward path k equal to 4. The four forward paths are: first forward path, straight forward path, the 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, and 6 to 7. This is the first forward path. Next, second forward path is 1 to 2, 2 to 3, 3 to 4, again 3, 4 to 5, 5 to 6, and 6 to 7. This is second forward path. Next, third forward path is 1 to 2, 2 to 8, 8 to 3, 3 to 4, 4 to 5, 5 to 6, and 6 to 7. This is third forward path. Next, for final forward path is 1 to 2, 2 to 8, 8 to 3, 3 to 4, 4 to 5, and 5 to 6, and 6 to 7. This is the fourth forward path. So in this problem, four forward paths are possible. Next, find the forward path gain. Forward path gain means multiple all values into the forward path. First forward path value gain of forward path 1, p1 equal to g1 and g2. Next, gain of forward path 2, p2 equal to minus g1 and g2. Next, gain of forward path 3, p3 equal to g1, g3, g4, h2. Next, gain of forward path 4, p4 equal to minus g1, g2, g4, h2. These are four forward path gain of above signal flow graph. Next, second step, find the individual loop gain. Individual loop gain means the path starting from one node and ending as same node. In this problem, two individual loops are possible. First individual loop is 3 to 4, 4 to 5, 5 to 6, and again 6 to 8. This is first individual loop. Next, second individual loop is 3 to 4, 4 to 5, and 5 to 6, and 6 to 3. This is second individual loop. So in this problem, two individual loops are possible. Then find the individual loop gain. Individual loop gain means multiple by the all values in the into the loop. First loop one value p11 equal to minus g1 g3 h1 h2. Next loop gain of individual loop 2. This is the multiple by the all values of individual loop 2. So p21 equal to G1, G2, H1, H2. This is the two individual loop of the signal flow graph. This problem, two individual loops are possible. Next, gain product of two non-touching loops. Two non-touching loop means combined into the individual loop into two. Then these loops are non-touching means the loops are non-touched loops. In this problem there is no possible combination of two non-touching loops, so three non-touching loops are also possible. So two non-touching loop and three non-touching loop are no not possible. Next up, calculation of del and del k. We all know that del means 1 minus sum of individual loop gain plus all possible combination of two non-touching loop minus all possible combination of three non-touching loop plus all possible combination of four non-touching loop. In this problem, there is no two non-touching loop and three non-touching loop. So del formula is 1 minus sum of individual loop gain. So 1 minus p11 plus p21. P11 and p21 value substitute into the del formula, and we can get 1 minus minus of g1 g3 h1 h2 plus g1 h1 h2. So del equal to 1 plus g1 G3 H1 H2 minus G1 G2 H1 H2. In this problem, there is no part of graph non-touching with forward path del 1, del 2, del 3, and del 4 values 1 because in this problem, first forward path all loops are touched. First forward path all loops, loop number 1 and 2 are touched, so del 1 value is 1. Next second forward path two loops are touched, so del 2 value is 1. Then third forward path 1 2 2 to 8 8 to 3 3 to 4 4 to 5 5 to 6 and 6 to 7. This forward path two individual loops are touched, so del 3 value also 1. Then fourth forward path 1 to 2 2 to 8 8 to 3 3 to 4 and 4 to 5 5 to 6 6 to 1. This fourth forward path two individual loops are touched, so del 4 value also 1. So in this problem, del 1 equal to del 2 equal to del 3 equal to del 4 equal to 1. So next finally moved into last step of the signal flow graph. Last step is find the overall transfer function of system using Mason's gain formula. The Mason's gain formula is t equal to 1 by del summation of k pk into del k. In this problem, number of forward path is 4, so k value equal to 4. So the formula is 1 by del into p1 plus p2 plus p3 plus sorry p1 in this formula 1 by del into p1 del 1 plus p2 del 2 plus p3 del 3 plus p4 del 4. In this problem was substitute into p1 p2 p3 p4 and del 1 del 2 del 3 del 4 values into the Mason's gain formula, then substitute all the values. We get v g1 g3 minus g1 g2 plus g1 g3 g4 h2 minus G1, G2, G4, H2 divided by 1 plus G1, G3, H1, H2 minus G1, G2, H1 and H2. Then rearrange the equation G1 into G3 and minus G2 plus G1, G4, H2 into G3 minus G2 divided by 1 plus 1 plus G1 H1 H2 into G3 minus G2. Next substitute, sorry, multiply into the values. The value equal to G1 into G3 minus G2 plus, sorry, into 1 plus G4 into H2 divided by 1 plus G1 H1 H2 minus G3 G2. This is the final value of the signal flow graph problem. The final value is the overall transfer function of the system. This various step by step procedure used to find the overall transfer function of the system. The signal flow graph is same step used to the find the overall transfer function. First step, we all know that the the figure block diagram means first to find into block diagram into signal flow graph. The problem also signal flow graph means directly solved into step by step procedure. Suppose the problem is block diagram means first converted into block diagram into signal flow graph. Okay, this is the first step. There is no the problem is the figure is signal flow graph is directly converted into first step, first procedure. Uh, uh, there is no signal flow graph means the problem is block diagram is first converted into signal block diagram into signal flow graph. Then second step, find the forward path gain. Forward path means the path travel between input node to output node is the forward path. So first step is find the number of forward path and forward path gain. This is the first step of signal flow graph. Next, second step is individual loop gain. Individual loop gain means the path travels between starting node to same starting node. This is the one of closed path. This is the individual loop gain. So find the individual loop and get the individual loop gain. This is the second step. And third step is gain product of two non-touching loop. Two non-touching loop means combined with two individual loop into two and get the these two loops are non-touching means this is the two non-touching loop combination. So find the two non-touching loops, then find the three non-touching loop and find the four non-touching loop. There is no four non-touching loop means next moved into another step. Two non-touching loop, there is no three non-touching loop means moved into third step. Find the two non-touching loop and we will get gain product of two non-touching loop. This is the third step. And fourth step is the calculation of del and del k. We all know that del equal to 1 minus sum of individual loop gain plus all possible combination of two non-touching loop minus all possible combination of three non-touching loop plus all possible combination of four non-touching loop. This is the del formula. And del k means del, already we know that del k means del for the part of graph which is not touching kth forward path. It means first forward path there is no touched. There is all individual loops are touched means the del 1 value equal to 1. The loop is non-touched being 1 minus non-touched loop values. This is the del 1 and del 2 and del 3. The problem number of forward path means forward path equal to 3 means the del value is del 1, del 2 and del 3. Number of forward path is 4 means the del value is del 1, del 2, del 3 and del 4. This is the find the this is the fourth step, calculation of del and del k. And final step is find the transfer function. Find the transfer function means by using Mason's gain formula, used to find the transfer function. We all know that Mason's gain formula del equal to 1 by del summation of k pk del k. This is mainly for a very important formula of signal flow graph. Final step, find the transfer function, find all value into this Mason's gain formula and we will get transfer function of the signal flow graph. So easy method to find the transfer function of signal flow graph. This topic is very very important of a gate exam. Repeatedly asking more questions of gate exam. So very very important topics of signal flow graph and block diagram. Very very important topics. Block diagram reduction techniques. We all know that 11 rules, 11 block diagram reduction technique rules used to find the overall transfer function of a block diagram. This 11 rules, mainly very very important rules. This rules is used to find the transfer function of block diagram reduction technique. Then another topic, signal flow graph. Signal flow graph is Mason's gain formula is very very important formula is used to find the transfer function of signal flow graph. So this two topic is very very important topic of control system uh, subject. This uh, this method is very simplest method of finding overall transfer function. Block diagram reduction technique 11 rules are used to find the overall transfer function, and signal flow graph is Mason's gain formula is used to the find the overall transfer function. So this method is very simple and easy method to find the overall transfer function. This topic is very useful for the gate coaching class. So I hope we are very understand. Uh, okay. Thank you so much. Thank you.